All right, so warm up today is, the first one is graphically. So you'll need a calculator, graph it, do the second calc 0, left bound, right bound, guess, all of that stuff. And so that's just about moving the 1 over, typing all the parentheses in there correctly. The next two you can solve sort of algebraically, but at the end you're going to need a calculator to get the answers. So we haven't done calculator problems in a few days, so here's your chance to kind of review those, because this would be on tomorrow's part of the test. So if you're watching at home, press pause, give those a try, and we'll come back and go over them. All right, let's go over these. First thing I want us to pay attention to is the directions. A lot of times we don't pay attention to directions, just jump right into the problem, and probably 95% of the time that's just fine. You know what you're doing, you get the answer right, and all is well. But the directions are important here. Careful, this is almost misleading, find all solutions from 0 to 2 pi. So that's not really all solutions, it's all solutions between 0 and 2 pi. We're only going to give that instruction for the graphic, for the ones that you graph. So you don't have to put plus 2 pi k on the end. You don't have to worry about the different rules. Just put them in the graph and find the answers. All the other instructions are going to say find all the solutions. So be careful about the difference between those two. All right, there's my graph. I guess I should note that I moved the 1 over, so subtract the 1. Minus tan x minus 1. My window is 0 to 2 pi. My y window doesn't really matter. You just don't want it to be too huge or too small. You just want something that looks, you can see what the graph looks like. Kind of a weird looking graph, but I guess that makes sense. When you combine the sine and tangent, you're going to get something unusual looking. Maybe even before we get started, there's 1, 2, 3, 4, 5, 6 zeros. So second calc 0. Prefer to list them in order so I don't get lost where I'm going here. So left bound, get to the left of the 0, enter. Right bound, get to the right of the 0, enter. And guess, you can just press enter again, and it thinks for a minute and spits out your answer. 0.375, 3 decimals. And repeat that process 5 more times. And yeah, fair enough. Maybe I should have picked one that had fewer zeros, but more practice, right? 0.990. I think there are 2 of these on the test. And I don't want to comment on how many zeros there are per problem because I don't remember. 2.883. But hey, if you can handle one with 6 zeros, you can handle one with 4 zeros. Or 2 zeros. 3.517. .132. I guess the only mistake people sometimes make on these is instead of using the calc 0, they end up doing the trace. And that gets you close, but it never gets you exactly there. It's like if you're just tracing, you think, well, that's pretty close, so maybe x is 4.14. And you're like, well, that's close, but that y value isn't 0. So don't use trace. I mean, it gets you close. But we don't want close. We want much better than close. Second calc 0. Left bound, right bound. Guess 6.024. Yeah. Oh, and finally one of these. I was waiting for one of these to happen. Remember, you're looking for the y value to be 0. But don't panic when it looks like that. You think, well, that's not 0. And I would say, well, it's pretty close, right? E is times 10 to the negative 12. So that's 11 zeros, and then 104, so that's really, really, really close to 0. Certainly to 3 decimal places, it would be 0. Three, open parentheses, sine of 2x, close it, close the 2x, close the sign, and then square it. So that's kind of tricky. Tangent of x, that was pretty easy. And then don't forget to move the 1 over. What's that?
Like when I put that equation in.
Number 2. Find all solutions algebraically. All. So that means we're going to have to do the plus pi k or plus 2 pi k. Use exact values when possible. That would mean if they're on the unit circle. So even though you have a calculator, you may not need it for everything in this section. All right, here's an easy one, and some of them really are this easy on the test. It's like we spend all our time doing the really complicated factoring and substitution stuff, and some of them are just that easy. Except that secant doesn't really, I don't really like that. So let's change that to cosine. So when we flip secant, we get cosine, and then we flip the other side, we get 2/5. So inverse cosine of 2/5. Inverse cosine of 2/5. 1.159 plus 2 pi k. So there's a couple things to remember. The plus 2 pi k, because all solutions. 1.159 is the answer my calculator gave me, but there's another answer floating out there. The plus or minus. For cosine, it's plus or minus. We didn't draw a picture, but maybe it would help. Cosine is positive in the first and fourth. So maybe that makes sense of doing a plus or minus to get the two answers. So the cosine rule is plus or minus. Number 3. Looks like it's going to be a factoring problem. Let's move the 2 over and then factor. I've personally kind of given up on factoring with the u's. If you still like that, you certainly can. But most of our factoring, I think, is simple enough to handle it. It's got to be 3 and 1. It's got to be 2 and 1. It's just a matter of where the 2 and the 1 go. I don't want the 2 across from the 3 because that would make 6. So let's put the 1 across from the 3 and the 2 across from the 1. I think I can make that add to positive 1 with a positive 3 and a minus 2. So factoring. A lot of factoring on the test. Hope you're, I think you're good at factoring by now. Sine of x equals 2/3. Sine of x equals -1. I skipped the step that many of you skip, where you set each factor equal to 0 and then do a little bit of math. Especially on that one, I skipped 2 or 3 steps. Set it equal to 0, move the 2 over, divide by 3. Sine of x equals 2/3. That is not a unit circle problem. So inverse sine of 2/3, 0.730 plus 2 pi k. And then what's the sine rule? Like where else, how do I get the other answer? Pi minus. Pi minus answer. 2.412. 2.412 plus 2 pi k. And sine of x equals -1. That looks familiar. That happens at the bottom angle, the bottom spot. So that would be, we could call it 2 different things. You can call it 3 pi over 2, or you could call it negative pi over 2. Either one would be okay. I'm going to call it negative pi over 2 plus 2 pi k. Yes, if you want to do so 2 ways to think about why there's only one answer for that. There's only one spot on the graph where the angle is, or where the y-coordinate is -1. That's probably the best way to think of it. The other way to think of it is, well, once I get one answer, the other answer is pi minus the first answer. So if I do pi minus -pi/2, what does that give me? 3pi/2, but that's the same spot. So I don't need that second answer because it's the same thing. So it's always okay to think about what's the other answer, but on a few occasions, just really the 1 and -1, there's only one answer. All right, so good warm-ups. So this calculator, we reviewed the cosine rule, plus or minus, reviewed the sine rule, pi minus. Didn't do the tangent rule. What's the tangent rule? What's that?
The 3 rule. I can't explain it.
Oh, that's the tangent 3 trick thing. But how do I get the other answer for tangent if I'm doing an inverse tangent? Yeah, the period's pi, so it's just plus pi k. So it's almost like I don't want to say there's not a rule. The rule is it's pi k rather than 2 pi k. All right, let's talk briefly about what's on the test. So a little bit of a test outline. So on Wednesday is the calculator part of the test. Two, solve by graphing. So that's the Calc 0 thing. Or second Calc 0, however you want to remember that. Just like the warm-up, the first warm-up we did. So those are, I think, pretty easy. Just make sure you get it in the calculator correct with all the parentheses and the squares and stuff. There's 4 equations. And then I don't know how else to phrase it other than there's 2 simple equations. I'll give you an example. 2 simple equations. Meaning as opposed to equations with factoring / algebra / substitution. The trig substitutions. Sine squared plus cosine squared is 1. Tangent squared plus 1 equals secant squared, and whatever the other one is. So 4 where you might have to use some or all of those. 2 simple equations. By simple equations, I mean cosecant of x equals -1.7. How would you do that one? Everyone's doing this. Like, yeah, change it to sine. Sine of x equals 1 over -1.7. And then now it really is a super simple equation. And you'd follow the sine rule once you got one answer. There's a bonus on that day because do you remember what the bonus is going to be? It's the quadratic one that won't factor. So that means the quadratic formula. So everyone will sing to themselves tomorrow. So what is that? 8 questions, 9 counting the bonus. Thursday, no calculator. So Thursday they'll definitely all be unit circle answers because you won't have your calculator. And I don't know how else to say it other than there's 10 equations. Of varying difficulty, of course, but it might involve factoring, algebra, substitution, and obviously lots of unit circle. Only unit circle for Thursday. So that's how it'll look. Again, so time I don't think will be an issue at all. And then Friday will be a catch-up day. If you miss one of those days, you can take it Friday. If there's anything else you're missing, then on Friday I'll hand it to you and say, please take this so I don't put a 0 in for your grade. Yes, so, oh, and speaking of that, it is open note, or open homework. Whatever you've got, whatever that you've got, not whatever your neighbor has, right? But whatever you've got. And then, obviously, then we'll have to make that stuff due on Thursday. Otherwise, it wouldn't be much of an open note if I took it up before the test. So the homework will be due Thursday. Good question. Anything else test related? I'm hopeful that we do well, but you got to know the unit circle. That would be the only thing I feel like that's the unit circle and factoring. Well, and the rules, plus or minus, pi k. Maybe it's more stuff than I'm giving it credit for.